Right, hi Joanna. I'm going to do question 2 of the calculator paper. I've just started off by drawing a graph of the function, and then it says find any extrema and state the nature. So we're looking for turning points on this graph. When we draw the graph, it's obvious there's one turning point at 0, 0. But what it's not obvious is whether there's any more turning points that we can't see on the screen. So it's better to, at this point, rather than searching for them using the max min on the analyze graph bit, it's better to go to the calculator and do it this way. What I'm looking for is the point where the gradient equals 0. So that's the point where the differential of f1 of x equals 0. So what I'm doing on the calculator, I'm saying I'd like to solve where the differential of f1x equals 0 in terms of x. So if you type that into your calculator, you've got to be a bit careful with it, because you've got to get the brackets in the right place. So solve is menu 3.1 and differential is menu 4.1, and you put your f1x in. When you solve that, you get these two values, minus 12 and 0. So there's two turning points. There's one at minus 12, would have missed probably if we'd just drawn the graph, because it didn't look particularly like there'd be another turning point. And I need to find the y to go with it, so I've just put the x coordinates back into the function. So I've said what's f1 of x when x is minus 12, so f1 minus 12, enter, gives me minus 24 over 25. So my first coordinate is going to be minus 12 minus 24 over 25. f1 0 gives me 0, so my second turning point is 0, 0. And I can tell from looking at the graph where the maximum and minimum are. I can tell that I'm going to get a maximum minimum at the maximum is going to be the minus 12 one, and the minimum is going to be the 0, 0, 1. Okay, so then it says where is f of x increasing? Where's it got a positive gradient? Well, now we know where the turning points are. We can say where it's increasing, because before when x is less than minus 12, it must be increasing because it's going towards a maximum. So we could say that x is going to be less than minus 12. It's going to be one place where it's increasing. Then it reaches the maximum point at minus 12 and starts decreasing. And you can see that it keeps on decreasing. It gets to this asymptote where x is minus 2. You can sort of read it off the graph. You can also tell that from the function, because it's at the bottom there's x plus 2 and x minus 3. So it would be the values of x, the bottom bits of the function, 0. So minus 2 is an plus 3. So it's decreasing. It's still decreasing on the other side of the asymptote, coming down to the minimum. At 0 it turns, and then it starts increasing again. When x is bigger than 0, it's increasing. Then there's a break for the asymptote at 3, but it's still increasing beyond it. So you'd say that x is increasing when x is less than minus 12, when x is greater than 0. But it's good then to say, but x cannot equal minus 2 or 3, because that's where the asymptotes are. Okay, so finding the zeros, again I'm going to use this solve function, and what I'm saying is I'd like to find where f1x equals 0, because that's, it's the values of x that make the y 0, that's the zeros of it. Again, I could look for these on the graph, but if there's one off the screen that I'm not sure about, or I don't think there is in this case, but this way it sort of avoids that problem. So I'm saying find the values of x where f1x equals 0, 0. It touches the x-axis at 0 when x is 0. By the way, this is why I've drawn the graph first. So f1x is defined for me because I've drawn it on the graph, so I can use the f1x now from now on. If I was going to do it without the graph, I'd have to define the function first and then use that defined function through the question. Right, finally it says find the gradient of f of x when x equals minus 3. So again, I'm going to stick with the calculator one, menu, 4, and it's this number 2, derivative at a point, the gradient, derivative differential at a certain point. So I'm going to use, a variable is going to be x, that's fine. My x value is minus 3, because it tells me that in the question. And then it's saying, what do you want to differentiate? Well, I want to differentiate f1 of x And in fact, I'm just going to pause this and type it out because it's sometimes a bit slow. Okay, so I just did that menu for 2 differential at a point, or derivative at a point, and I've differentiated f1x when x equals minus 3, and it gives me minus 3/4. So there we go. I could then go on to use that to find a tangent at a point, that sort of stuff. You know, I could find f1 of minus 3. That would give me the x, the y, and I'd have the gradient, and I could use that to find the c. Right, so that's all of question 2. Because this program's playing up a bit tonight, I think I'll do the part F of. Okay, so part F question 1 is saying, given that formula, 5,000 over 2 minus 0.9 to the power of x, will the company's profits keep growing or will it tend to a limit? So basically, what happens after a lot of time? Does it just keep on going up forever, or does it go back down to 0, or does it go into negatives, or does it reach a limit? Is there a certain value? So I'm gonna type in the formula, but for x, the number of years that has passed. In fact, it should be n, shouldn't it? But number of years that have passed. I need to put a lot of years, and probably the easiest way to do that is to type in the formula, and then if you have a look at the pi button on your calculator and you click on that, it gives you this little menu. And here I've got a very big number of infinity. Enter. Okay, and you can see that that this will tend to an infinite amount of time. After loads and loads of years have passed, the profits will be 2,500 every year. That's it. So when it's saying, will it tend to a limit? What happens, after a long time in a long-term study, that sort of stuff? Put infinity into the function and see what the function does. So it'll either give you undefined because it's gone to infinite, or it'll give you 0, or it'll give you a number, and then you can use that number. And that's that. Okay, let me know if there's any other questions, and I'll get into the video.